So hi everybody, and welcome to Explain Factor. Today I'd like to make a little tutorial on how to use an aviation computer. I have the Pulley CRP1 computer, and I'm gonna help you use this part of the computer, which is for wind, ground speed, drift calculations. It will work for any of computers that do not have any wind gauge, wind scale here. If you have an extra part here that rotates, you need other instructions, but I'm going to explain you how to use this computer for a question using this window on which you can write and draw with your pencil. I'm quite simply going to try and answer a typical ATPL question from the navigation module. The question states an aircraft tracks a radial 200 degrees inbound to a VOR station with a magnetic heading of 10 degrees. So you have a VOR station here. Your heading, magnetic heading, is 10 degrees. And you're inbound the VOR, inbound 200, radial. The radial is 200, so you're tracking 200 minus 80, that's 20 degrees. So your track is 20 degrees, but your heading is 10 degrees. So the drift here, the angle is 10 degrees. After being overhead the VOR station, your aircraft tracks another radial, 90 degrees. So you turn right to track 90 degrees. Inbound with a magnetic heading of 80, so your magnetic heading is 80 degrees. Okay, the true airspeed is 240 knots, and the magnetic variation here is 5 degrees west. For west you need to subtract, and for east you need to add. So you're following first a inbound radial 200 inbound the VOR. Your magnetic is 10, so your drift is 10 degrees right. That's this angle here, which is the drift angle of 10 degrees to the right. Then, what is your true heading? Well, your true heading here is 5 degrees because you're heading 10, your track is 20, but the variation is 5 degrees west, so it's 10 degrees minus 5, that's 5 degrees. Your true heading is 5 degrees. Okay. After this, after inbound, having overflown, the VOR, you are going to take radial 90, but your magnetic heading is 80. And your true heading will then be 75 degrees, because you'll have 80 magnetic heading minus 5 variation is 75 degrees. Now comes the use of the computer. So what you have to do is set the speed. Now we have two sides for this scale. We have a scale written L for low. Low is for low speeds from 40 to 150 knots. And the other side is H for high. It's the high scale from 150 to 950 knots. We're flying at 240 knots, so we'll use both sides. I'll use this side. What you need to do is put the center dot on 240. So you go to 240 low. Alright. Now you have that, maybe I should use the other side, to be honest. Whatever, you can use both sides. 240 might be better this side. 240 is here. So you set the dot on your scale to 240 knots. No, it's not, it's here. There we are. And then you need to put here on the index the true heading. You don't put the magnetic heading, you don't put the wind, etc. You put the true heading. The first leg is 5 degrees. So you put 5 degrees under the index as a true heading. and you draw a line along the 10 degrees right drift. This is the drift, 10, 20, 30 degrees. These are the drift angles, and you need 10 degrees, and you have to draw a line along the whole section of 10 degrees drift. You can do this on this window. Then you work on the second leg. For the second leg you have a true heading of 75. So under the index you put 75, and you still have a drift angle of 10 degrees to the right. So you draw a line here on the 10 degrees drift to the right. What you then need to do is rotate to bring this intersection point under the central line. And there we are. This central point now is on the central line. And what you can read here is 140. The fact is the wind comes from the opposite, which is plus 180. It's 320. So 140, you need to add 180. The wind comes from 320 degrees. This is where the wind comes from. And what's the strength? Well, it's graduated from 10 to 10, so you've got 10, 20, 30, 40, 50. So we've got 50 knots. And this is actually the answer, and the correct answer is 50 knot of wind from the 320 degrees. And there you have answered the question. Thanks for watching, and don't forget to like and subscribe if you've enjoyed the video.